Hey, so today we'll be doing two important numericals on Nlm. That will be very much important for you, uh, for I can say uh, exam point of view. Very important. Okay. One problem is a block of mass 25 kg is pulled along a horizontal plane by a force inclined at an angle of 45 degree with horizontal. The frictional coefficient between block and the plane is 0.25. The block travels at uniform velocity. The block travels at uniform velocity. What will be the work done? What will be the work done to displace the block? Why mistake? So in this type of problem is there. First you need to draw the free body diagram. You know it already. Free body diagram. Suppose this is a plane horizontal plane is there. This is the block 25 kg. So you know this is 25 into 9.8 is the weight, this much Newton. This is the normal reaction. And a force applied at 45 degree. So this is the horizontal axis, and at 45 degree a force is applied. So you need to get the value of the force also. And as you know, if the force is applied in this direction, so this will be your F cos 45, this will be your F sin 45, and this will be your coefficient of friction in this direction. Definitely coefficient of friction is between this block and the plane, so the friction will be in this direction, F of F, which is equal to mu into R, and R is equal to this. Actually here directly R is not equal to this. R plus F sin 45 is equal to this 25 into 9.8. So R plus F sin 45 is equal to 25 into 9.8. So I need to get that value 25 into 9.8. 25 into 9.8. The value is 245. So 245, and R I don't know. F sin 45, F by root 2. Sin 45 is 1 by root 2. So it is F by root 2. Therefore R is equal to 245 minus F by root 2. Now this value is very important, because in the frictional formula we need to put the value. So F of F is equal to mu into R. Mu is 0.25. They have given here 0.25 coefficient of friction, and R is 245 minus F by root 2. So this is your f of f. Now frame the equation. See, f cos 45, which is the right hand side, this side, that should be equal to the frictional force. Okay, so frictional force is this f of f, and therefore f cos 45 is what? And the block get displaced. Okay, it is said that the block get displaced also. Okay, and the block travels at uniform velocity. Okay, the block travels at uniform velocity. So that is also mentioned over there. Okay, so that is also mentioned over there. The block travels at uniform velocity. Okay, so what you should do first is, if cos 45, this component of the force is in equilibrium condition will be equal to mu into r. That is the frictional force. Okay, that is the frictional force. Okay, now here we can write this. If cos 45 is again f by root 2, and that is frictional force is 0.25 into 245 minus f by root 2. Now you can do one thing. 0.25 is nothing but 1/4. Okay, so this is from decimal to fraction if you are converting. Basic simple math. And f by root 2 over here. So therefore f by root 2 into 245 by 4, that is 240 by 4. This is coming 245 divided by 4 is coming 61.25. 61.25 minus this f by root 2. So 1/4 of, so you can say it is by 4 root 2. Now we just bring this one that side. So take f by root 2 common. 1 plus 1 by 4 is equal to 61.25. So f by root 2, 1 plus 1 by 4 is 5 by 4. That is equal to 61.25. Therefore f by root 2 is equal to 61.25 divided by 5 by 4, which is nothing but into 4 by 5. So 61.25 into 4 divided by 5, it is 49, becoming 49. Now therefore f is equal to root over 2, 49 root 2. Okay, so 49 into 49 into root 2, or I can say 49 root 2, that is 69.29. 69.29. We are getting 69.29. Okay, okay, actually I don't need f, I need f cos 45, because you see in the diagram, if you see in the diagram, if you want to get the work done, so that should be the direction of, that should be in the direction of f cos 45. That the work done should be in the direction of f cos 45. So work done is equal to force f cos 45 into the displacement, that is 5. So I need value of f cos 45, not the value of f. So I can keep in that way, like I can, because f cos 45 is nothing but f by root 2. So I keep f by root 2 is equal to 49, and therefore work done is equal to, work done is equal to 49 multiplied with root 2. So we'll be getting 69.29. 69.29. sorry, work done, sorry, extremely sorry. Force is given, force is given uh, 49, force is given 49, because f by root 2 is the component of the force, na, f cos 45 multiplied with 5. So 49 multiplied with 5, that is 245, 245 joule. That is the work done in that case. So do you understand? Work done is equal to force into Fs cos theta. So F cos theta is F by root 2. F by root 2 is 49 Newton. Oh, you got it already. So 49 and S is 5 meter. It is given in the question. So 245 joule. This is the first question. Very important question and very important topic to be discovered, because you can see it is work done problem. You cannot escape it, because work done, only work done, question from work done, uh, it is, sometimes the concept will be, amalgamated, like concept of friction within the work done, because this is a concept where friction is actually came into action. Okay. And the another problem that I must discuss, topic, a cubic block of mass m is sliding down in an inclined plane at 60 degree with acceleration of g by g by 2. What will be the value of coefficient of, what will be the value of coefficient of kinetic friction? What will be the value of coefficient of kinetic friction? So it seems to be a kinetic friction problem, but it is in the acceleration, so it is kinetics problem. Okay. So because you already know about the concept of friction in mechanics 1, so that is why this type of question is stated, like, you know the concept, so you can apply it. I have discussed in the class also, and again I am basically revising the concept with you. So block is kept over there, 60-degree inclination, and it is coming down with an acceleration, and that is g by 2. It is given g by 2. Now we know, if this is the mass, so this is mg, that is weight, and this will be your, this will be the again 60-degree, so this is mg cos 60, and this will be your mg sin 60, okay. And they have asked you the value of mu k, actually coefficient of kinetic friction. Okay, so how do we get it? Because if it is coming down, friction will come, act in this direction, f of f, and that is equal to mu into r, and here r is in this direction, perpendicular to the plane. Okay, so r is equal to mg cos 60 in equilibrium condition. So now if you compare these, sidewise forces, that is mg sin theta, sin 60, because it's coming down, so I have to write that component first, because it is coming down in that way, minus f of f is equal to ma, that is f net is equal to ma, and a is here g by 2. So mg sin 60 is root 3 by 2 minus mu into r, f of f, mu into r is mg cos 60, mu k actually kinetic friction, and that is equal to ma. M into a is here g by 2, is coming down with g by 2, it is written. So now what I can do, I can cancel out all mg's from all these, points, and uh, here we have root 3 by 2 minus mu k cos 60 is also half mu k by 2, and here it is half. Again, all 2's can be cancelled, and then directly mu k is equal to root 3 minus 1. Root 3 is 1.7 something and minus 1. So you can do approximately, it is 0.71 something, like 71. This is the value of mu k. This is a very important question, very important topic. Okay. So stay tuned with these videos. I'll be uploading some more topics for your quick revision. Thanks for watching.